Hi, this is page 4. What is the specific heat capacity of the metal? Okay. What the Q for the the heat from the water. The heat that the water absorbed was 3670 joules. So what is the specific heat capacity of the metal? Let's see. Now, remember, in your calorimeter, there was the metal, and there was the water. So the water got this much heat. Where did it get that heat? It got it from the metal. The metal gave heat to the water. So that means the metal lost some heat, right? Yes, the metal lost some heat. So, how much heat did the metal lose? Well, the metal must have lost 3670 joules, because the heat was only going into one place. It was going to the water. It couldn't go anywhere else because you were using 2 coffee cups. The heat didn't go to the table. The heat didn't go to the air because the coffee cups were there to block it. It's not perfect, but it's almost perfect. So, the heat of the metal is equal to the negative of the heat of the water. Okay? Because the water gained heat. The metal lost heat. Okay? You know, the heat doesn't come from nowhere. Heat comes from a place that loses heat. So the metal lost this heat, water gained that heat. Okay? So now, I know that is for the metal. And remember that, so this is, I'm going to solve for C, okay? C, if I divide both sides by everything else, that makes okay? So all I have to do is find the mass of the metal and the change in temperature of the metal. Now, from the previous page, we know that the temperatures were for the metal here, it was in boiling water before, right? That means that was its initial temperature. That was the temperature of the boiling water that was given in the previous page. And then the temperature that you end with was, okay, well, how do I know that? Remember, on the previous page, there was a picture of a thermometer. The water was at 35.0 degrees Celsius. So, if you waited long enough, the water should have been at the same temperature as the metal, because when you wait long enough, everything goes to the same temperature. Unless they're live, or unless you turn them on or something. So, what is the delta T? Delta T is 66.0 degrees Celsius. Is it 66 degrees Celsius? No, it's 66.0 degrees Celsius. That has meaning, okay? So now, the C, this is going to be minus 3670 joules. The mass of the metal, remember, from 2 pages ago was 252.252 grams. And then the delta T, that was 66.0 degrees Celsius. And so that all equals to C. Oh, okay, there's something wrong here. I have done this backwards. It is the final temperature minus the initial temperature. It is not 101 minus 35. It is 35.0 minus 101.0, because this is a T final, this is a T initial. You have to do T final minus T initial. Sorry about that. Okay. That was the T final. That was the T initial. Subtract. You get negative 66.0 degrees Celsius. That is important. Okay, so this means minus 3670 joules over the mass, 252.252 grams. Also on the bottom is the negative. Too messy. Sorry. Okay. Pencil. Smaller. Just a little bit smaller. A little bit small. A little bit small. A little bit small. Is that better? No. A little bit small. A little bit small. A little bit smaller. Okay, never mind. 252.252 grams. Negative 66.0 degrees Celsius. Okay, that is the C. So, let's find it. .220. There are only 3 significant figures. So C equals 0.220 joules per gram per degree Celsius. You must have the correct units. Joules per gram per degree Celsius. That's C. Joules per gram per degree Celsius. Okay. Let's identify the metal. 0.22. Which one is 0.22? Remember, we were trying to decide if it was silver or tin. 0.220, it's tin. Huh. We were trying to decide between silver and tin? Oh no, I'm sorry. We were trying to decide between silver and lead. Yeah, that's what it was. That was from the page 2, or page 3. Silver or lead. Which one is it? It must be silver. Now, why is it not tin? It's not tin because we found the density, remember? On a previous page, the density was not the same density as tin. It was the same density as silver or lead. It was just as close to silver as to lead. So, the specific heat capacity tells us that it can't be lead, it must be silver. Of course, in the real lab experiment, we wouldn't give you silver. It's too expensive. We wouldn't give you lead either, because lead is supposed to be dangerous in some forms. That's it. Thank you. Next page.